Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hello and welcome to Hardware to Save a Planet. I'm very excited to have my very good friend Bret Richmond here with me, Director of Engineering for C6 Forest to Farm Biochar. We're going to be talking about wildfires and their impact on climate change. C6's core mission is to reduce the risk of wildfires, and they're doing it in a way that I think is really smart and something I haven't heard about before. Their method also has knock-on benefits for the planet and agriculture that we'll hopefully get into. Bret shared some numbers with me before the show that I thought were really shocking, so I wanted to share those here. In 2021, the US had 59,000 wildfires that burned 7 million acres. Those fires were responsible for 8% of total CO2 emissions in the US that year. So it's a really big problem. I'm excited to learn more about what Bret and C6 are doing about it. As I said, Bret is a good friend. We first met at Olin College. He's now the third Olin alum we've had on the show, so big shout out to Olin. We also worked together at Synapse for many years before he left to work with C6. He was a leader at Synapse who helped us strengthen our mechanical engineering team and systems engineering capability, which has had a really lasting impact for our clients. I could go on and on about how much fun Bret and I have had adventuring together over the years, but to keep this brief, I'll just say that I've always looked up to Bret as someone who has his priorities straight and doesn't waver for the wrong reasons. I've often found myself admiring the life and career decisions Bret has made. So I'm really excited to hear about this latest career change. Bret, thanks a lot for taking the time to do this with me.
Yeah, you bet. Thank you for the opportunity. I appreciate the intro. Very nice to hear. Yeah, thanks so much for the opportunity.
Yeah, excited to do this. So Bret, since we first met way back in 2002, you've always struck me as someone with kind of this extraordinary appreciation for the natural world. I think you've shown that with your career choices and some of the things you do in your free time and stuff. I've never asked you this, but I'm curious, where did that come from? I think you grew up in West Texas and Arkansas. Did I have it right? Yeah, I'm just curious, does your love for the natural world go back to your childhood? Did it come somewhere else along the line?
Yeah, it did. I did grow up. Actually, grew up in the Texas Panhandle and then in Arkansas for most of my childhood. And I spent a lot of time outside on my grandfather's kind of little cattle operation and fishing a lot and just that kind of stuff outdoors all the time. So that's definitely where it came from. My grandparents and my dad in particular, it was kind of an escape. I grew up in sort of, I guess I'd say, a lower income household, and the outdoors are accessible to everyone, or most everyone. I'd say there's a lot of discussion recently about how privilege fits into that, but at least where I grew up, the outdoors were accessible to everyone, and that was a good outlet for me as a kid.
And has climate change been something that's been on your mind too? I mean, I know back when we were in college together. And actually, maybe just a quick shout out, you're also a founder of Big Belly, which was episode 3, I think. We had your co-founder, Jeff, on the show to talk about Big Belly. But I know, at least at that stage, you were thinking about how can you address some of these big sort of waste management problems and climate challenges. And I know Texas is a place where there's a lot of oil and sort of energy infrastructure and business going on. Has climate change been a big kind of thing on your mind, or is that more recent?
I would say it's more recent since kind of high school into college, in that transition period. When I was younger as a kid, I did have a sense that there was something changing just based on my own experience. And the sort of anecdote I would provide there is I heard stories from my family about fishing and how that was back in the 70s and even into the 80s. We fished a lot on the Arkansas River. And I just heard these fantastical stories about the number of fish and bait fish and size of fish. And then when I was fishing with my dad as a kid, everything was super hit or miss. And there was a lot of discussion about irrigation pressure up in Kansas and all this kind of stuff. I had some sense that something was going on, I think. And I was fortunate. I had an opportunity in middle school sometime, I think, to go to summer camp that was focused more on, I guess I'd say, just the natural world and the environment. And I learned a little bit about it there. But then as I got kind of out in the world, started college and stuff, it became more top of mind for me, I guess I would say.
Mm-hmm. That's good. I never thought to blame my lack of fishing skills on climate change, but I'm going to use that. I like that.
No, it's good. It's very convenient. So
one thing that always stands out to me about you is that you took some time away from your desk job to spend summers working on a trail crew. And I'm curious to just kind of get your perspective on that experience, why you chose to do that. And is there any tie between kind of that experience and what you're doing now with C6?
One of the reasons I did that was that when I first got out of college, I took a job with a really small industrial design and mechanical engineering firm in Seattle. And I worked with them for a couple of years. It was a pretty classic high pressure startup environment. In those kinds of shops, there's a lot of time spent on sales and looking for work. Of course, you got to do the work. There's not a dedicated team doing what you do so well, Dylan. So I got a little burnout from that. I learned a ton from it. I was on a really good team, but I thought, well, I'm going to take a little break here. And it was just sort of organic from there. I started during my break going out to volunteer with Washington Trails Association around the Seattle area just to do day trips on trail crews there. And I did that for a few weeks, of kind of a couple or a few days a week. And it was a nice outlet. It's the kind of work I like doing. I met some really amazing people. And then it just came up that there was an internship that summer for an assistant crew leader. And I said, well, that's interesting. And so the crew leader on the Seattle area cruise, he set me up with the office, so to speak. And I put in an application and I did that for a summer and then became a kind of independent crew leader after that and did that for altogether a few summers. And what was really fun about it was all the crews I worked with were volunteers. And the jobs I had during the summer were backcountry trail crews. So these are people who are self-selecting to go out for a week at a time, as much as 15, 16 miles into the backcountry to work hard all week, and do a lot of manual labor to build new trails or fix trails or reroute trails or whatever. And so I learned a lot about leadership in that experience and about working with volunteers and also just about the sort of skill set there around manual labor in the woods, that kind of thing. I had some of that from when I was a kid, but I learned a little bit more about some forestry topics and so on. And that has been a good background for me at C6. I've certainly learned a lot more about forestry and adjacent topics since I've been to C6, but I think that experience with Washington Trails Association kind of piqued my interest whenever I saw the C6 opportunity in front of me. So
cool. Well, if nothing else, there were many days when I was digging through my email in the office, thinking about you out on the trail with a lot of jealousy. So at least you did that. So let's talk about wildfires. I'd love your perspective on this. Why have we seen so many wildfires recently? And actually, specifically, I'm kind of interested to know, to what extent is that a result of climate change? And to what extent are those wildfires contributing to climate change?
Yeah, so I think the primary challenge here, at least in the West, is that somewhere just after the turn of the 20th century, when the Forest Service was still in its infancy, there were some events that occurred that basically some large fires and stuff that drove a culture of wildfire suppression, kind of rapid wildfire suppression almost across the board. And it's important to keep in mind that most of the forests here in the West are evolved to be fire adapted. So it's actually healthy for them to have periodic wildfires because it helps control the density of the forest, helps control pests, and so on. And it even helps promote new tree growth. I think that there are conifers that their seeds don't activate or germinate until they've been exposed to fire. And so after decades of this wildfire suppression, what's happened is that the forests have become more and more dense. And you can see photos comparing kind of the early 20th century back in almost early photography days to today. And it's pretty evident how much denser these forests are now. And climate change is now sort of exacerbating the issue. With the droughts we're seeing, sort of increased temperatures across the board. Now that those forests are, in many cases, overstocked, when they're exposed to these long drought events and increased heat, when there are fires triggered by lightning or other causes, it's a lot easier for those fires to get out of control and become extreme wildfires. So now we're in this positive feedback loop where we had this overstocking issue, or continue to have it. And now the forest can't deal with fires. They're not resilient to fire. And so when fires are triggered, lots of carbon's released into the atmosphere, increasing climate change impacts, and so on. And it's this vicious cycle that we're in. I could not impress upon people enough. There's a couple of layers of impact here in my mind. One is the direct, or kind of the immediate impact of fires. So there's a lot of wildfire smoke, and that has impacts on local economies, regional economies even. There is kind of the aesthetic of it, right? Where we live here in the Menal Valley, a couple of summers ago, we had some pretty big fires near our beautiful Valley Highway. And now you drive up the highway and it's like, oh, there it is. You can't escape it now. The bigger issue that I like to impress on folks is that those are carbon sinks that are no longer available to help us fight climate change. Yes, they're overstocked, and yes, they could be made more healthy, and that's work that we're trying to contribute to, but they're still carbon sinks. When you burn 7 million acres of forest in a year, that's a significant amount of natural carbon sinking solution that's suddenly gone, and it's not going to be available again for many decades, if at all, in some cases, especially with really extreme, super hot fires. So
some of the other guests we've had on the show are really focused on permanent carbon storage solutions where we're pumping it underground or something and it's going to stay there forever. And sometimes I feel like that's kind of put up in comparison to forests, which aren't as permanent. So maybe you can help me understand the life cycle of a tree and from the perspective of carbon sequestration. So a tree has leaves or needles that photosynthesize and sequester carbon. That tree will then store that carbon for its life. And then when it dies, what's happening to all that carbon?
Yeah, I mean, if it doesn't burn up, then it slowly decomposes, right? It's just part of the carbon cycle, basically. And I think the thing to keep in mind with this is that we need to entertain all the solutions that we can to maximize our carbon storage. And I think maintaining our forests and other habitats that are great carbon sinking tools for us, if you want to think about it that way, is really important just in terms of, it's almost like, we remember the beginning of the pandemic, we were talking about flattening the curve. It's a little bit different than that, but it's kind of similar in that we want to sort of modulate the amount of carbon that we're sending to the atmosphere in the first place. And so we just want to maintain our forests to do that, bottom line. Certainly it's the case that we've emitted at this point more than we can recover with those natural solutions, right? So, but we need to maintain those natural solutions to our benefit. Otherwise, it just makes the problem more and more challenging.
What is your solution to address the wildfire problem specifically?
Yeah, so specifically on that, what we're looking to do is to help accelerate the terms that are used a lot, or accelerate the pace and scale of forest restoration in the region. And that forest restoration essentially boils down to thinning back closer to those historic levels so that the forest is more resilient to any kind of wildfire activity. So the challenge is that a lot of the biomass that results from those restoration or thinning operations doesn't have any value And that's kind of dependent on how close you are to a pulp and paper mill or those kinds of things. But for much of where we are here in central Washington, there's not an economic outlet for that biomass. So it essentially has no value. And that makes it very, very difficult for particularly public land managers to address the issue because it's a massive cost to them. So the idea is if we can take that biomass and essentially just pay for it, right? All we're doing is saying we're going to buy that biomass, then we can create valuable products from that to justify buying it. And then that capital that we inject into the forest restoration system will ideally help accelerate those activities. So it's kind of on the wildfire end of things, it's kind of an economic play. We're just looking for a way to say, just bring us the biomass, we'll give you money, and you can use the money to help with restoration.
So instead of a fire going in and basically burning that excess biomass that's in our forests, you've created a demand that will incentivize people to go in and take that biomass out of the forest.
One of the topics that comes up a lot is prescribed burning. And that's an important tool in the toolkit, as I understand. But in a lot of places in this region, the forest is already overdense for prescribed burning to be feasible or safe. So oftentimes what will happen is these restoration thinning operations will happen to take out a certain amount of the biomass. And I should say this is often in the form of small diameter trees. It's not like we're going in and pulling out all the little brush and stuff. We're talking about trees that are kind of in the like 6 to 10 or so inch size class that are ladder fuels. And so we're talking about taking out small trees, not taking out every little twig and pine cone that we find. But once that thinning has happened to a certain level, then they can go in and do prescribed burns to help with more of the kind of final treatments to help keep the organic matter down. Yep.
And also, and maybe this isn't a significant piece of it, but by not burning those small diameter trees, you're not releasing their CO2 back into the atmosphere.
Yes. Yeah, absolutely. And this is, I don't want to go too far down the rabbit hole here, but one thing that often happens is that slash piles are generated from logging operations. And since those small trees don't have value, they end up in those slash piles. So it's not only that these acres don't get treated or these forests don't get thinned, it's that when they do, also, that material is often just burned, which means that carbon goes right into the atmosphere.
Mm-hmm. Okay. So that's probably a good segue into what are you doing with all those small diameter trees that you've created demand for? What's the next step once you kind of buy those?
Yeah. So what we're doing is the underlying motivation was to just find wood products, essentially, that would be very valuable in the market to justify paying for the biomass. So the co-founders of C6 a few years back did an assessment of potential options. There's a lot of stuff out there you could think about. Like there are a lot of fruit orchards in this part of the world, and they use a lot of posts and poles for their operations. So yeah, you can take small trees and you can turn them into poles. And there are other options like that. But what they decided would be most beneficial is to make biochar and other pyrolysis products from the trees. So biochar is made by basically heating it up in the absence of oxygen, which is what pyrolysis is. And it generates kind of a solid, which is the biochar. What we're focusing on in our pilot is to take the opportunity from converting this biomass, in particular to biochar, to then address another issue in the region, which has to do with our agricultural soils. So much of the agricultural soil in the Columbia Basin, kind of central and eastern Washington, is very sandy and carbon deficient. And so we see this opportunity essentially to take carbon from where we have it in excess in our forests and then redistribute it via biochar to our agricultural soils to help make those soils more healthy and productive. And the other products The liquids in particular, we're looking at options for those. I think the future holds some promise for how to essentially kind of apply every molecule to the highest and best use, so to speak. But for now, we're really focused on the biochar and engineering that biochar for specific agricultural applications.
So there's somebody buying the biochar from you.
That's right. Yeah.
And that's agriculture operations.
We will sell it to agricultural customers, and we can, long story short, like the price of that biochar justifies what we're paying for the biomass, right? That's the goal.
Right. Okay. Oh, interesting. Okay. So I didn't really fully grok this, I guess. But let's say there was a boom on teepees and everybody needed a teepee in their backyard. So there's huge demand for small diameter poles. That would still solve the problem you're trying to solve. It's really the biochar is a means of creating a demand for these small diameter trees and getting them out of the forest.
That's right. And it has the added benefit of when you add it to the soil, you're sequestering carbon for at least hundreds of years, if not thousands, at a fairly substantial scale.
That is actually a fairly long-term way of sequestering this carbon. It's not going to decompose in the soil and emit back in the atmosphere.
Yeah, I mean, there is a decay rate to it, right? And it depends on the soil temperature and so forth. But we're projecting that over 100-year lifespan, you maintain something like 90% of the carbon. So,
oh, wow.
And I should say, we're not selling it to farmers for the value of sequestering carbon, right? We're selling it to farmers because it has real benefits for the soil. And the upshot of that is the biochar is it's the carbon matrix from the cellular structure of the biomass, right? So what it is, or what it turns out to be, is like a little sponge that holds and retains a lot of water, and also a little home for microbes. So we're seeing that there's growing interest, especially as fertilizer prices continue to increase and so forth. There's growing interest in the soil microbial communities that might be helping ward off other diseases and pests, that might be helping to retain more water or retain more nutrients and so forth.
Okay.
So the biochar is a good tool for helping to retain more water in the soil, increase that microbial population, and help retain more nutrients as well.
Okay. So you're also solving the water problem. These soils are able to retain more water a little bit.
Yeah. Well, I don't know if we're solving it, but we're helping to impact it. Yeah.
Yeah, you're helping with the water problem too. Okay. So very multi-factor benefits here. That's very cool.
It is consistently challenging for us to tell our story because there's so many facets to it. But
yeah. Can you sell carbon offsets as well?
We can. We're pursuing that. And actually, we're just getting our preliminary life cycle analysis completed right now. So yeah, we've done an initial push on that. We're getting our LCA, and then we'll be kind of finalizing the details on that in the coming few months here.
Okay. I imagine that must drive things like how far away do you place your pyrolyzers from your sources, from the forest where all the biomass is coming from. Is that right?
Absolutely. It's actually great because it helps keep us honest about the process and about minimizing the carbon intensity of the process itself. I think the carbon market we're finding it's pretty variable in terms of lots of things because there's a lot about it that's new, right? And we're figuring out how to negotiate it. But, at the very least, it is driving a lot of thought about distances from the biomass to the plant, distance from the plant to where the biochar is being applied, and what that means for diesel emissions in particular.
Are you familiar with Charm Industrial?
Yes. Yep.
Okay. Yeah, we talked to them for one of the episodes, and that was their big thing is they're taking agricultural biomass and converting it to bio oil. But their big thing was like, let's not ship that biomass around because that's really big and fluffy. Let's make these small mobile pyrolyzers that we can bring to the edge of the cornfield, I guess.
Yep.
Just to really minimize so is that kind of the direction you're thinking as well?
Well, I think what we're looking at is on the fluffy note, we're looking at how to get the biomass out of the forest. And there's different options about chipping it closer to the forest and then hauling the chips or whatever. But what we sort of landed on is logs are fairly dense even small diameter logs. And we know how to haul those on log trucks, and that all just kind of works. And so let's not impose new process onto those folks. Let's just take logs, which are pretty dense, and process those. And I think that's working for us. But longer term, I wouldn't be surprised, especially as like larger electric vehicles, trucks, and so forth become more mainstream. Some of the calculus on this might change, but right now this logs are working because they're less fluffy. But point taken, that is a big challenge.
And where are you in the process? Do you have a system up and running and you're taking in logs and turning them into biochar?
Where we are is we have a site selected and are working through letter of intent to lease that. We're, I would say, 75% through system design, and we're kind of completing our planning stage essentially in the next couple of months here. And then we're into fundraising for the plant. So that's the major push. It's still ahead of us. We're preparing and building the artifacts and the network that we need for that. But yeah, we haven't actually built anything yet at that scale. We did about a little over a year ago, I guess, we did get a small research reactor. It was on like a 5x10 flatbed trailer. And we ran it for a month and a half or so. And we learned an incredible amount from that. It was a batch-based system. So you're basically just putting bucket loads of wood chips into this little reactor. And then we had to get an air quality permit for that. So we had to kind of monitor our flue gas and stack emissions. And that was a process that was very challenging to control. And we learned a ton from that. And actually just a couple of days ago, we're working through some of our system requirements, and we're kind of remarking like, how much was that experience informing what we're talking about today to essentially weight our requirements and figure out which are more important than others. So that's been a really good experience for us. And we're looking forward to having more machines under our control and starting to get them up and running.
So yeah, maybe could you describe kind of physically what happens with so the logs show up on a truck. Where does the hardware come into play?
Yeah, well, actually, there's a lot of hardware. So we unload the trucks, and there's a seasonal aspect to the logs, both in terms of their moisture content and in terms of just how much of that biomass can be transported, because you imagine in the winter when it's snowy, there's more forestry operations going on in the Cascade Mountain area than you would expect in the wintertime. But that transport does kind of drop off a little bit. So we do have a big space to deck logs and store them to kind of get us through that seasonality. And then about what we're planning on right now is essentially 5 days a week for a single shift every day. We'll chip logs. So they're going to be basically taken by a front-end loader, loaded onto what's called a live deck, where they get dropped onto a conveyor. And then from there, they go to a chipper. Before that, one of the decisions we had to make and are currently making is, do we need to debark the logs? Because the bark contains more ash and it potentially injects some inconsistency for our product. So it's a big, expensive piece of equipment. So we're trying to decide whether we really need it. And then we'd be collecting bark and then have to find an offtake for that, which is not so challenging. But anyway, from there, we chip the logs, and then we're going to set up a storage system for chips. So from that sort of 5 days a week chipping, we go into a 24-hour operation. So we need a little storage buffer there for chips to get us through a 7-day cycle. So then got a big room full of chips. They get conveyed 24/7 into a kind of indoor pre-processing center where they're milled to the particle size that we want for our product. So that could be anywhere between like 3 and 12 millimeters. And they're screened so the particles are pretty consistent in their size. And then they're dried. So we have a dedicated dryer in the system, because like putting the biomass in your reactor to dry it is not the most efficient way to do it, and it adds some variability to the product. So we have a dedicated dryer, and then the particles go right from the dryer into the reactor. The reactor is a continuous feed system. Just to give you a sense of scale, it's processing about 1.5 tons oven dry particles an hour. So 3,000 pounds an hour, basically. That means that we're taking in about 17,000 green tons of logs per year with our pilot system. So that translates to about 1,000 acres of forest restoration treatments every year, give or take. These are all rough numbers, but the reactor is taking in about 3,000 pounds of dry particles per hour. And once the biochar comes out of the reactor, we are looking at basically storing it very short term and then loading it into large commodity belt trucks to be hauled to our agricultural customers. So we have customers who want the stuff in large enough volumes that even putting it into like big cubic yard sort of bulk bags doesn't really make sense. They want big trailer loads of this stuff. The other major thing that happens is that vapor I talked about before, we have to make sure that that is within standard to be emitted to the atmosphere. The Department of Ecology here in Washington has very stringent standards for that. So that vapor goes through basically an incinerator to ensure that it's decomposed down to basic carbon dioxide compounds, basic combustion compounds, so that it can be emitted to the atmosphere. At the end of the day, about 50% of the carbon in the biomass will make it out in the biochar to go and be sequestered in the soil. So again, at some point down the road, we'll capture that vapor and we'll create value from that as well. But as we launch, we're trying to keep things as simple as we can, essentially.
Yeah.
It's kind of where there's more product development complexity is because there's a lot of chemistry involved, is in that vapor stream and how to derive value from that.
And to this point, you were telling me this before, every step that you just described is achievable with off-the-shelf systems or commercially available systems that you can purchase and put together. Is that right?
Yeah, that's right. And a lot of it is kind of old school sawmill equipment, right? A lot of the conveyance and materials handling, and we got a big chipper and that kind of stuff. That's all well-known sawmill technology, essentially. The reactors they're a little more novel, obviously, and there's been a lot of development on that front in the last, I'd say, 5 years or so. There's kind of a history in this field of these little reactor manufacturers popping up, and then they don't have enough of a market, essentially, to keep going. So I think now there's enough demand for this type of biomass processing that a couple of these reactor manufacturers have gotten onto pretty stable footing and are doing reasonably well. And so, and what's nice is they're sort of optimizing around flexibility in the product. So when we're making biochar and thinking about how to optimize it, we can control the particle size. Our feedstock's kind of fixed, right, given our mission. So we're going to get Douglas fir and ponderosa pine chips. I mean, that's basically what we're going to be working with. But we can change the particle size, we can change the moisture content, and then we can change the temperature and residence time inside the reactor. And there may be some things we can do to pre-treat the feedstock as well. So the reactor manufacturers have done enough to de-risk the system so that there's good temperature control and accuracy, and same with residence time and so forth. So that means that we have a lot of flexibility with our product formulation and product development.
I was thinking about this. You're one of the most talented mechanical and systems engineers I've ever worked with. I'm curious in all of this. You're not developing kind of bespoke custom hardware at this point, but where in this are you kind of flexing that engineering muscle?
It's a big system to integrate, right?
Mm-hmm.
So there's a lot to do with system design in terms of the mass and energy balances, figuring out the requirements based on those process flows, kind of gaming out equipment manufacturers and how reliable their equipment's going to be and that kind of stuff. Been doing a fair amount of program management. There's only 3 of us on the team, but someone's got to take the PM baton, and we trade that around a little bit, but I've been doing a fair amount of that as well. So yeah, it's a lot of systems engineering in terms of system architecture, process development, and requirements and risk management too. So
thinking about the future of C6 and wildfires and everything, yeah, I think you said your system can do, like one system can process enough biomass to manage 1,000 acres of forest. Is that right?
yeah, about that. That's what our pilot scale is set for. Yeah.
And just kind of putting that up against, what did we say, 7 million acres were burned in the US just in 2021.
Yeah.
That's just kind of a mind-boggling number. Do you envision C6 scaling to a point where it can address the problem at that scale? Is that the vision?
Yeah. So what we're envisioning is to scale within our region to address the scale here. And there's a couple of things going on there. One is in the detail of how the Forest Service and other land management agencies are looking at addressing the challenge. And so one of the things they're looking to do, for example, is to potentially do a staged approach to where they're focusing restoration efforts. So as an example, the first might be to build a network of fire breaks so that if there is an extreme wildfire that starts, it's kind of maintained within a smaller area. So that means out of the gate, you're not necessarily trying to treat all these acres at once, but you're being strategic about where you're doing it. And then what might follow on from there is more fuel breaks and restoration projects like close to roads so that more of those forest roads become better fire breaks as well. And the reality is the folks who are actually doing the forest restoration work, they're not going to be up in the wilderness doing this work, right? They're going to be doing it where the forest is accessible to do this kind of work. So
gotcha.
There's a lot of strategy in how that actual restoration work is playing out. We also know on the other side of the operation that we could sequester many, many hundreds of thousands of tons of biochar in the Columbia Basin agricultural area. So there's no problem with that. Then it's a matter of how we scale the system or what have you. Right now, we're just trying to get a pilot up and running. We've done some thinking about regional scaling. I think there's a lot of opportunity there, but it's something that we'll focus on more down the road, obviously. It's really easy in the site that we're looking at right now to scale kind of in increments of our pilot scale. And at that site, we could probably scale to be kind of 8x what our pilot scale is, something like that. To your point, it's not huge relative to the challenge, but given the strategic nature of where the restoration work is going to be happening, we hope that scaling at that facility and then potentially expanding to other regional facilities will be sufficient to at least make a big impact on the challenge.
Okay. Last closing questions. How optimistic or pessimistic are you about the future of our planet and why?
Well, unfortunately, it kind of depends on which day you ask. That's a little bit of a mixed bag, I'm afraid. But there are a lot of reasons to be optimistic. I see definitely increased awareness of the challenges that we face and increased action, right? And that happens, or I'm seeing that at every level from local and regional levels. We're seeing more sort of climate-oriented coalitions being built and trying to determine how to have the best impact in their areas. We're also seeing it at higher, kind of larger institutions, like the opportunities that the Inflation Reduction Act have or are bringing to different concepts are really inspiring. I think a couple of things that when I read about them, they kind of make me feel a little more pessimistic. I think one is there can be in the sort of cultural dialogue a bias toward the perfect solution. And I think we have to be pragmatic about this stuff. I think the classic example there is EVs. And I know everyone would love to flip a switch and have electric vehicles tomorrow, but that's just not a reality. And so how do we make that transition in the most graceful way that we can and just recognize it's not going to be perfect? I think it's important to keep that sort of mindset. And the other thing too that I see every once in a while is like focus on technology first instead of specific problems and people first, and then applying technology where it's needed. So obviously coming from the product development world, we're pretty heavily steeped in find the problem and then apply the solution. Don't find the solution and apply it wherever it looks like it might work. So, but again, a lot to be optimistic about.
I see that kind of tension of the perfect solution versus the kind of what can we do today to make an impact, like your EV example, a lot. And it almost feels like we need both ways of thinking. We do need eventually to transition to electric vehicles, just to extend that example. But in the meantime, we've got to do something to address this massive fleet that's on the road today. Yeah, somehow, how do we find the right balance kind of between those things? Who is one other company or person doing something to address climate change that's inspiring you?
There are two good ones that come to mind. And just real quick, one on the EV example is Blue Dot Motor Works. And Tom Gursky and his team, I think, speaking of that EV transition, he's addressing that head on. And I just think it's a huge challenge. There's a big system that he's working against. And I think he's doing a good job of trying to jujitsu that in certain ways. But the only other one I would note, I know you asked for one, but is Running Tide. I just like how they're using technology to maximize the benefit of natural systems to sequester carbon. And I just think that's great. Where can you use technology as a leverage to get the most out of nature, I think is a good way to think about this.
Yeah, no, they're awesome. My kind of high level understanding is they're growing kelp or seaweed in the ocean and then sinking that to the bottom of the ocean as a means of storing carbon, right?
That's right. Yep.
What advice do you have for someone who isn't working in climate today, but wants to do something to help?
Oh, gosh. Well, I think for me, finding C6 was I just had my eyes open. So I learned about it in the local newspaper, and then I reached out and asked, and we got a conversation going. So,
cool.
But I'd say just find something to get involved in, even a little bit. If you have the privilege to do that. I know there are a lot of people out there who have a lot going on with work and kids and so forth. But if you can find a few hours here or there, I think find something that has a real impact and just go check it out. Even if you go and get involved, volunteer for an hour or two, you'll find that you can get sucked into it and you're probably doing a good thing. The other thing that happens with that too is, for example, I find LinkedIn to be a great tool, but if you're looking around in places like that for where to have an impact, it can be a little challenging. Everyone's trying to sort of like solve the huge problems, and actually you can have a ton of impact by just going into your community, finding somewhere where you can have a positive impact and just starting there. So, and you'll find too that that's where the real network is oftentimes, right? You're going to meet people there who know somebody who's doing a bigger thing in your region that you can plug into and that kind of thing. So that's what I would say. Just go into your community, find something, get involved. So
please set a good example for that. Bret, that was really fun. I learned a lot, and I'm a big believer in what you're doing. Really excited to hear how things progress. Thanks for sharing the story with us.
Yeah, thank you. It was my pleasure.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, and Google Podcasts, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.